students. In this video we are going to learn the problem under the topic of your complex variable, which is there your subtopic of your complex variable is Cauchy's integral theorem. So the last video we have seen the proof of your Cauchy's integral theorem, and for generalized for Cauchy's integral theorem we have seen, and as well we have done for before that video also we have done Cauchy's theorem, right? So problem we are going to learn which is based of all the three, and the major role which will come for your Cauchy's integral problems. Okay, so let me go with the first problem. Evaluate integration of the curve e power z by z plus I pi into dz over each of the following counter is to see each counter you are going to evaluate how this integration part. Okay, so modulus of z is equal to 2 pi is the first one, modulus of z is equal to pi by 2 is the second one, and modulus of z minus 1 is equal to 1 is the third one. So generally what is the Cauchy's integral theorem says? Integration of f of z by z minus a dz can be explained, right? So what you have to do, first you can write it what is your a point in that curve, what is the point you are going to write it, that is what's been given in the solution. So first you have written Cauchy's integral formula, which is f of z by z minus a dz is equal to 2 pi I into f of a. Okay, so here e power z by, given problem it is given z minus, it is a plus, we need it as a general as a minus, so I'm taken out for the minus of minus I pi into dz. So f of z e power z is your f of z function as per general form, you will get e power z. And what is your a point? A point is minus I pi. And what is your point here? Point of z is nothing but here 0 comma pi, because a point you have a minus I pi, right? So x value is 0, imaginary part alone is there, it is 0 comma minus pi. Now you can go for your first one. What is that? The curve how it has been there is a contour, modulus of z is equal to 2 pi. Okay, is a circle with a center 0 comma 0 and the radius of 2 pi. So modulus of z has been defined, it is a circle, right? As we know already, it is a circle with a center and the radius of 2 pi, because z you know, right? And modulus of z we can take it as a circle equation which is equal to, you will get a 2 pi. So the point is 0 comma minus pi. Whether the point will lies inside the circle of your radius which you have taken 2 pi with a center will be origin or outside, you can take it. The circle will become bigger than of your pi, isn't it? Because of 0 comma 2 pi. So 0 comma minus pi will be inside your curve. So Cauchy's integral will exist. So you can see that graph, you can understand. See here it is there 0 comma 2 pi, and everywhere it is have your circle with the center 0 comma 0. So 0 comma minus pi will be your outside the 0 comma minus pi is there inside your circle. So the Cauchy's integral theorem will exist. Clear? So as per the Cauchy's integral formula, integration of the curve e power z by z plus I pi into dz is equal to 2 pi I into f of minus I pi, because as per the formula 2 pi I into f of a, right? So what is your f of a here? It is a minus I pi. So f of z is e power z. So f of I pi is nothing but, f of minus I pi is nothing but e to the power of minus I pi. So 2 pi I of cos pi minus I sin pi, I can write it because e to the power of x is nothing but cos x plus I sin x. Here e power minus x, it is cos x plus I sin x, right? E power ix. So what will happen? Cos pi will be a minus 1, sin pi will be a 0. So I will get only minus 2 pi I, right? So this is your first part result. So similar, you have to compare the second part, whether the point has been given, it is a p of 0 comma minus pi is inside or outside. Modulus of z is equal to pi by 2 is the second question. It's a circle, isn't it? What is your, it is a center of origin, right? A center with origin. Then the radius is nothing but pi by 2. So the point is 0 comma minus pi. Obviously it's supposed to be outside, because you have it as a radius itself is a pi by 2. So sure it will go outside. So it is outside means by the Cauchy's theorem it will go equal to 0. You can see that. See, as per this graph, you can see the point is 0 comma minus pi by 2 is there in everywhere. So approximately 0 comma minus pi will be here. It's supposed to be outside. Clear? Now you can go for your third part. It is a modulus of z minus 1 is equal to 1. So here it's a circle, but center will be at a point is a is equal to 1 because z minus a value is 1 here. The center is 1, that is 1 comma, there is no imaginary part, it is a 0. And the radius is equal to 1. The point p of 0 comma minus pi, it lies in the whether it is inside or outside. How we can take, you can see from the graph. See, it is a center with 1 comma 0, you can take it. With the radius is 1, you can draw the circle and the point of 0 comma minus pi approximately here. If you need, you can make it a pi value is 3.16. Now the minus point will have like this, so obviously it will be outside. Or you can go with a point with a mathematical way, it is you can take it with AP. With a point of A and B, the distance is equal to square root of 1 minus 0 the whole square plus 0 plus pi the whole square. You can do, it's supposed to be 3.296. So sure, it's supposed to be a greater than of which r is equal to 1. So the point which is done at 0 comma minus pi, it's outside. If it is in outside, as per the Cauchy's theorem, it will go equal to 0. It's clear na? Now you can go with a one more example. Evaluate integration of the curve z square plus z plus 1 by z minus 2 the whole cube into dz over the circle modulus of z is equal to, over the curve modulus of z is equal to 3. So little changes in this question. What is that? As per the previous problem, I can go ahead, but denominator I have, when instead of z minus a, I have z minus a the whole power 3. So here you are supposed to use it only with generalized of Cauchy's integral theorem. So first you can write it, what is a point as per the given question. Instead of a places I have a 2. So at a point, the point z is equal to 2 lies inside the circle modulus of z is equal to 3. So now you can use your Cauchy's integral formula. As you know, we have to use only the generalized because you have a denominator is in the power. So as for the formula, I am writing in terms of only f of z minus a the whole power n plus 1 in the left side. Remaining I am taking to the right side in the generalized formula. So it will become 2 pi I by n factorial into f power n of a. Okay. So now you can go with the function how it is. F of z is there because as per the formula I needed f power n derivatives. I need to find up to nth derivatives. That means what is your n value here? Z minus a the whole power 3 is there. So I have to find up to 2 because 2 plus 1 will give a 3, right? So first you write what is your f of z. It is z square plus z plus 1. Then f dash you can find, it is 2z plus 1. F double dash of z is 2. So actual is required f power n of a. That means f power 2 of a value is 2 here. So f of 2. So nothing to replace here in the right side of z terms. You can write it as it is 2. And also a is equal to 2 and n is equal to 2. So when we have the formula, you can write it. Integration of your curve f of z term and z minus a the whole cube, right? This z minus 2 the whole power 3 dz is equal to, as per the formula, 2 pi I by n factorial into f power n of z, right? N of a. Here n value is 2, a value is also 2. So 2 factorial into f double dash of 2. So which is equal to 2 pi I by 2 will get cancelled because f dash of 2 value is 2, isn't it? So you will get 2 pi I. So now you can get the answer, the complete integration answer, which will go, it is 2 pi I. Is it clear? So remember in this Cauchy's integral formula, Cauchy's theorem, and for generalized Cauchy's theorems, where and all we are supposed to use it. So if you have a point which you have that it is a point, whether it is inside or outside, you are supposed to check. If it is an inside, the Cauchy's theorem will exist. If it is an outside, it will go for, as per the Cauchy's theorem, it will go 0, right? The integration, complete integration will be equal to 0. If it is inside, you can use Cauchy's integral theorem, which is equal to, what is that? 2 pi I if you have a term and you have to write it here, f of z terms, right? Is it to be replaced at a point of a, f of a to be your final answer. And the third type, you are supposed to use such a generalized. When you have to use your generalized Cauchy's integral theorem, when you have the denominator will have in the format of z minus a the whole power n plus 1 format, you are supposed to use it. Okay, that's all. Thank you.